This video is going to teach you how to do unit conversion, going from one system of units into a different system of units. Every physical quantity has its own units. When I say physical quantity, I mean things like distance, time, speed, and units are the units of measurement used to describe those physical quantities. So seconds, hours, meters, things like that. Those are the units. So the few steps that you need to use in order to convert from one system of units to another one are listed here. First thing you want to identify is what are my original units and what do I want to get into? Do I want to, maybe I've given seconds and I need to get into hours. The next thing you want to do is use conversion rates written as fractions using a series of these things multiplied together in order to cancel out the units you don't want and to leave you with the units that you do want. So this is the most important step here, is to take conversion rates and turn them into fractions, and then multiply your given quantity by these fractions in order to cancel out the units you don't want and give you the units that you do want. The last thing you'll do is actually multiply all the numbers, perform the arithmetic at the very end. What you want to do is set everything up first and then do the math at the very end. So when I say conversion rate, it's something common, like I gave the example of 60 minutes is equal to 1 hour. That's a conversion rate. This one here, 1 meter equals 3.3 feet. What we want to do is take these conversion rates and write them as fractions. So all I'm going to do is just divide both sides. Let's say I divide both sides by 3.3 feet. Now I have a fraction on the left-hand side. On the right-hand side, 3.3 feet divided by 3.3 feet, that's just the number 1. So 1 meter divided by 3.3 feet is the number 1. That's a conversion rate, but written in the form of a fraction. I could have just as easily have divided by 1 meter. And so in this case, I get the number 1 is equal to 3.3 feet divided by 1 meter. Both of these fractions could be used in order to convert from one system of units to the other one. Which one you'll use depends on whether you started off with meters or whether you started off with feet. We'll do some examples to figure this out, but the key thing here is now that I've written it in the term of a fraction that's equal to the number 1, I'm allowed to multiply any number by this fraction without breaking any rules of math. I haven't changed anything because you're always allowed to multiply by the number 1. Some things you need to be aware of. When your units are written as fractions themselves, things can get complicated. So make sure that when you have units that are written as fractions themselves, that you use a horizontal fraction bar. An example is the units of density, grams per centimeter cubed. Instead of writing it like with that slash, I would write it as grams divided by centimeters cubed, or meters per second, meters per second squared. Make sure it's very, very clear what's in the numerator and what's in the denominator. Another trap is when your units have exponents in them. Be very careful, because when you may need to raise a conversion rate to an exponent, make sure that you raise everything in the conversion rate to the exponent. So in this example here, 200 meters is equal to 5 laps. So if I divide both sides by 5 laps, I get my conversion rate. So 200 meters divided by 5 laps is equal to the number 1. That might be a useful conversion rate for the problem that I'm working with. These are units of distance. Perhaps my problem actually has an area. Maybe I want to figure out area and I'm converting units of meters squared to laps squared. The conversion still holds true, but I need to make sure that I square everything. So 200 squared, meters squared, divided by 5 squared, laps squared, is equal to the number 1 squared, which is of course equal to the number 1. So just be really careful that when you need to square a conversion rate, you square everything. Let's do a quick example here to give you a feel for how to set up these problems. I'm taking a quantity of 23 grams per centimeter cubed. I'm going to write it as grams divided by centimeters cubed. The 23 stays up in the numerator. It's 23 grams per centimeter cubed. I'm trying to get this into units of stones per reed cubed. So let's start off up here with the conversion rate that 3 stones is equal to 60 grams. I'm going to divide both sides by 6,000 grams. And so I get my conversion rate that's equal to the number 1. So 1 is equal to 3 stones divided by 6,000 grams. I'm not going to do any math right now. I'm going to leave it just like that. The other conversion rate I have, 30 centimeters is equal to 31.7 reeds. I am going to divide both sides by 31.7 reeds. So I get the number 1 is equal to 30 centimeters divided by 31.7 reed. Notice that I'm not working with centimeters though. This is density, so it's centimeters cubed. So I need to cube my entire conversion rate. So the conversion rate that I really need for this problem is 30 cubed centimeters cubed divided by 31.7 cubed reeds cubed is equal to the number 1 cubed. I cubed everything. Whatever you cube on the right-hand side, you got to cube on the left-hand side. Apply it to everything in those parentheses. So now I finally have some conversion rates that I can use to do this problem. So let's start off with 23 grams per centimeter cubed. I have grams that are in a numerator. So I want to choose a conversion rate that has grams in the denominator. The fraction that I set up had grams in the denominator. If I had set that fraction up in the opposite way, you're allowed to invert that fraction, basically just flip it over, because the number 1, you can also flip that 1 over too, and you just still get the number 1. So my fraction that I set up is good. 3 stones divided by 6,000 grams. The grams in the numerator cancel with the grams in the denominator. That's how I know I chose the correct version of that fraction. And now I need to get rid of centimeters cubed. I see those in a denominator, so I need a fraction that has centimeters cubed in the numerator. Again, I set up my fraction correctly, but if I hadn't, I can flip that fraction over and it still is equal to the number 1. So 30 cubed centimeters cubed divided by 31.7 cubed reeds cubed. Centimeters cubed cancels with centimeters cubed. I am now in my units that I wanted to get into, and so now I am finally able to actually multiply all my numbers out, perform some arithmetic. So I have 23 times 3 times 30 cubed divided by, this is an implied, the number 1 down there, so just 1 times 6,000 times 31.7 cubed. And again, I'm in stones per reed cubed. Now I just do a little bit of math on my calculator. 23 times 3 times 30 raised to the 3rd power divided by 6,000 divided by 31.7 raised to the 3rd power. And I get 0.00975 stones per reed cubed. And there you go. That's how you can do unit conversion. Go back and watch this video over and over again if you weren't able to follow along, but I'll give you some practice and you can work on this on your own using this video as reference.